Well, hello. In this lesson, we're going to multiply some polynomials. Now, before we do that, we're going to review a concept you did back in elementary school, but area of rectangles. Why don't we draw a rectangle, kind of a square, and another rectangle. Let's talk about these for a minute. If I told you that this side of this rectangle was 4 inches and this side was 7 inches, then you should be able to tell me what is the area of the rectangle. Well, you multiply length times width, right? So 4 times 7 is 28. But then what is inch times inch? Well, inch times inch will be square inches. Yeah, it's important to multiply the units as well. Now, if I told you that this was x feet long and this side was also x feet long, then what is the area of this square? Well, x would be x squared, and then feet times feet would be feet squared. So it'd be x squared feet squared. That's a lot of squares. And let's talk about this one. If I told you that this side was 5, but this side, oh man, I don't remember exactly what it was. I think it was twice that or so. This was 2x. So then what is the area of this rectangle? Well, it'll be 5 times 2. The area would be 10x. Right? 5 times 2x would give us 10x. I didn't give you units, but if you really wanted to, you could say, arbitrary units and arbitrary units. So it'll be units times units would be units squared if you wanted to, if we're talking about area, right? So hopefully that makes sense. Let's make one more rectangle. That's a lie. We're going to make a few of them in this video. Rectangle, and I'll tell you what. This here is 6. This top part up here, oh man, I forget how long this is. This is x. I don't remember how long. But this piece here, that's definitely 9. What is the area of this whole big rectangle? Well, in order to do that, we can find the area of just the small ones. The area of this box right here would be 6 times x would be 6x. But this box here, this side is 9, but the length is the same as what it is here, right? So 9 times 6 would be 54. So the area of the whole big thing would be the sum of this little box plus this box. So it would be 6x plus 54. That would be the area of that box there. Now, length times width, the length here would be 6 times, and the width is, it's not x, it's not 9x, right? If I walk x miles and walk 9 more, I walk x plus 9 more. So what we're doing here is 6 times this top, 6 times this. And you remember from first semester, if we were to distribute that 6, look at that, that's how we come up with this area here. The reason why we're doing these boxes is to model what distributing is. What distributing a 6 times x and a 6 times 9, what happens, you get these boxes like that, and you do that. I'm laying that down because today in this lesson, when we talk about multiplying polynomials, it's the same concept, but on a bigger scale. So first thing I'm going to do is I'm going to show you the box method. And the box method says this. Let's suppose that I have a big old box like this. And this piece here, oh man, this is x. And this piece right here is 5. And then on this side, this is 2x right here. And this piece right here is 7. If we were to extend where I made these breaks, then go ahead and find the area of each one of the 4 boxes. Go ahead and press pause and hook that up. Ready to go. All right, so hopefully in this box you got 2x squared. This box you got 7x. This box was 10x. And this one, 5 and 7 is 35. Right, so the total area of this box here would be, we'd add up all of these things, right? So we would have 2x squared plus 10x, right? This plus 7x plus 35. It would just be adding up all four of those things. But as we talked about it in the past, if you look at this, I got 2x squared. I got a squared term. I have two linear terms, two single x terms, and then a constant term. I can combine like terms here and come up with 2x squared plus 10x plus 7x is, 17x plus 35. So the area of this big box is this. Now, the way that we get there, another way to do that is by a method called the distribute method. Let's talk about what's happening here. How long is this side right here? Well, this side, it's x plus another 5 units long. So this would be x plus 5 times the length here, right? So this would be 2x plus another 7, 2x plus 7 units long. So what we have here is the length right here, x plus 5 times the width. And here's what's happening. We can actually think of this as like a whole thing by itself. We're going to make this a red circle. And just like we did up here, right? Just like we distribute the 6, I want to distribute this x plus 5. Well, what's going to happen here is I'm going to get 2x times x plus 5. But then I'm also going to do plus 7 and distribute the x plus 5 to the 7. See how I took this x plus 5 and I distributed it to both terms inside of here. If I was to distribute the 2x now, watch this. If I distribute 2x times x and 2x times 5, 2x times x times x would be 2x squared plus 10x plus, and then I got to distribute the 7, plus 7x plus 35. Look at that. It's the same thing as what we did when we added up the boxes here. So here's what's up. The box method is just another way of doing the distributive method. Now, you may have heard the distributive method called another name. Let's do another example. You may have heard it called FOIL. Here's the thing. If you've heard it called FOIL, then you've seen this before. And if you want a refresher, go ahead and Google FOIL. But here's the thing. I'm not going to teach FOIL. I teach the distributed method. So check this out. So here we have x minus 4 times 3x plus 2. I'm going to take this whole first term and distribute it to each one of these things. Right? So it's going to be 3x times x minus 4 plus 2 times x minus 4 we're going to distribute. We get 3x squared minus 12x plus 2x minus 8. Combine like terms, and our final answer should be 3x squared, negative 12x plus 2x is minus 10x minus 8. So when I distribute these two polynomials together, or two binomials together, this is our product. Now, if you want, you could check it with a box. Check this out. This side, let's make this x. And even though it's x minus 4, just make this side negative 4, right? It'd be x plus negative 4 on this side. And then you could do 3x, think of it as plus 2 up top. And then do the boxes. You should see that it comes out to here. And